This is Team R2's presentation of the Tic-Tac-Toe bot. This is a project for Engineering 141. We are in Section 51. Team members Ben Bryla, Kyle Carroll, and Preston Frazier, thank you for watching. Here are our goals for the project. Our first goal was to develop an unbeatable strategy for the game of Tic-Tac-Toe. We had to then implement this strategy in a MATLAB program, writing all of the code for it. Once we had this code, we needed to write code that would allow a Mindstorms robot to play Tic-Tac-Toe. The next step was to integrate the Tic-Tac-Toe logic code and the robot code together, and to create our final goal, a working NXT robot that will never lose at Tic-Tac-Toe versus a human, or it can also play itself. So our first step was to develop the logic of the game. Our team decided to use a strategy-based method instead of a recursive fitness method, which were the two options that we considered using. The recursive fitness method requires less code, but it actually takes longer to operate because it has to check a lot of possibilities every turn to see which one gives the computer the best possibility of winning the game. On the other hand, the strategy-based method requires more code initially than the recursive, but it actually operates more effectively and efficiently because it's less, and it's also less complicated to write.
The way that the strategy-based logic works is that first, the computer is going to check to see if it can make a winning move. If the winning move is not possible, it is going to try to block the opponent, as that is the second most important move it can possibly make. The third most important move that it can make would be to take the center of the board, because that offers the most possibilities of blocking the opponent, and also it gives greater chances of winning. If the center is full, then the computer tries to move it to a corner space, because it is much easier to win or block an opponent from winning if you own two or more of the corner spaces. And lastly, if the center and the corners are both full, the computer moves into an empty side space. The method for scanning the board and placing the ball. After each move was made by the robot's opponent, a color sensor initiated and proceeds to scan every space on the board. So basically, we had to write a code that would tell the robot to read what every specific spot on the tic-tac-toe board read. Then next, we had to be able to turn that and put it back into MATLAB, which would go back into our strategy-based game logic. Then the strategy-based game logic would put it back into the robot so the robot can make its next move. And it would keep going until either the robot won, the player won, which shouldn't be possible, or the game was a tie.
This is our robot playing human versus computer, where the human goes first. Whenever the human makes a move, the robot scans the entire board in order to determine where the human made its move. And then to determine where the robot is going to go, it's going to consult the decision tree that we have in code. It can be seen here. And it will then move accordingly. And our human player played fairly smart, so he was able to tie with the robot. And now we're going to have the robot play against itself. The algorithm for this is going to be the same as playing against a human, only it will basically be doubled up against itself. The markers in the queue are alternating, so we can tell what move the robot has made, and the X's and O's for the moves will also be outputted in the MATLAB window. Because the robot is playing against itself, it knows exactly where every move is made, and thus we don't need to scan the board after each move. And because the robot has the best strategy against itself, it makes a tie.